It's going to have Megan's head right in it. Let me see if I can move that a little bit. Well, just smile pretty for the camera, Megan.
Okay, good. All right. Good job, okay. If you could hold your white stuff, and if y'all could just look around, everybody seems to have done one up and one down. Now, and that definitely is different, right? What key feature about our graph tells us whether they're going to go up or go down?
Negative.
What is negative or positive?
A.
The leading coefficient A, right? Let me see. Can you hold yours up? Take a look at Ebony's. What else do we know about hers other than whether it goes up or down?
It crosses the edge. Say that again. Crosses the Y. Y.
What do we call when it crosses the y-axis? The y-intercept. Okay, so hers has a y-intercept. Are they always going to have a y-intercept?
Yes.
Yeah.
It's always going to have a y-intercept. Is it always, but look at her other one. Is it always going to cross the other axis?
No.
Okay, so what do we call the place where it does cross the axis?
The vertex.
No.
Hold it up for them to see it.
Centroid.
The y, let me set it over here. The zeros. What's another word for it besides zeros? Who stole my marker?
The root.
Oh, I got it. Okay, we've got our x-intercepts. I'm going to take over here. Our roots are zeros. Okay?
What's another word?
Roots.
Oh.
X-intercepts, roots, zeros, and there's one more? Good job, Solution.
Now, let me ask you a question. Are you going to have always one root only? Can you have one solution? How many solutions can you have? Two. You can have two, right? Can you have roots at all? Solutions?
Look at Ebony's. Ebony's, the reason we picked hers is what do we know about her solutions? What?
Yeah, look at that one right there.
One of them don't even cross the x-axis, is what she said.
Good job, Diane.
Awesome. It doesn't cross it, so how many real solutions is that one going to have? Zero. I mean, I'm going to keep picking on you because you had the most different ones of all. Hold it up one more time for me. How many times is her other one touching the x-axis? Once. Okay, so we have one solution. Now you can relax, Ebony. Cheyenne, can you hold yours up? And then how many solutions does Cheyenne's have? Well,
Well, she has two.
Each one.
Each one.
each one has two. And we said because it's a degree of two, it's going to have two solutions, or it can have zero real solutions. There are two imaginary, or two of the same. That's where Ebony's just had one, right? So two of our key features, y-intercepts and our x-intercepts and all of the other words that go for it. Can you hold yours up for me, Keely? What's another key feature that most of you all have, what everybody has on the graph, but most of you all have one of each on them? One's up and one's down. More mathematical.
What do you?
One's maximum, one's
Oh, good,
minimum.
Bryce.
Bryce, what was it?
One's maximum, one's minimum.
Oh, excellent. Excellent.
Oh, yeah.
Maximum minimum. You talk about the vertices, right?
And guys, a key term that came up when I started reading through this that we didn't use is that's the turning point. Okay? So when you're looking at your graph, it turns right there. What do we call that turning point? Our vertex.
And how many turning points do we have on a parabola, a quadratic curve?
How many times does that graph going to turn?
One. Yeah, it's not a trick question.
Yeah, it's only going to turn once, right? All right.
Mr. McKallip, I want to ask everybody a question. I was wondering, you know, it's like unkosher words some students use, like top of the hill and bottom of the hill. What is the top of the hill? What is another name for it?
Rises.
Is You have the top of the hill.
Vertex.
What is it?
It's a
Yeah.
vertex, but it's gonna be what to the top of the hill? On top of the hill. Yeah, like this one. Down here. There's another course.
Vertex.
Maximum, right? Top of the hill. Bottom of the hill. Minimum. You see what I'm talking about? Sometimes, some books, you don't use those wordings, so just make sure, if you see that, you don't want to get off. Not think, there's something else different. Okay? Makes sense, doesn't it? Okay.
Right, max is at the top, min is at the bottom. And we know that we use that when we were talking about our domain and range. We say our range has either a top point or a bottom
That's
point.
right.
Okay, if y'all could clear your whiteboards and put them away.
Yeah, just put them on.
And Miss McKallip, I'm going to say sometimes things, if I throw you off, and say, what do you mean? So, yeah, I didn't mean to do that, so I'm
No,
sorry.
no, you're good.
Good job,
Okay, guys. Do you all recognize the three forms of the equations that are up on the board? Okay. Okay, we've gone through all of these, right? We've gone through standard form, we've gone through the intercept form or factored form, and we've gone through the vertex form. But now that we're going back and looking at these key features, can we determine which key features that form is going to tell us without doing any math? We're talking about, we can look at it and we can tell right away what are those key features, okay? So our standard form, can anybody remember what key feature that tells us just by looking at it? Well, we know it's positive, so we would know whether we have a max or a min. Good. Do what? It opens up because it's positive.
Y-intercept. Good job.
The y-intercept. What is the y-intercept for this one?
24.
It's 0.24.
Good job, Jazz, because it's the point, right? It's the point.
And how would you find again the y-intercept is 24 right offhand? What did you do?
Look at C.
Looking forward.
So C is 0.24. So C is the vertex. Okay? Okay, now look at the next one, factored form. Factored form right here. Intercept form is another name for it. What is something when I look at this without doing any mathematical work, whether in my head or just I can look at it, what can I tell? The x-intercepts, or what's that other word for x-intercepts? Zeros, solutions, roots. And so when I look at this, what do I know the x-intercepts are going to be? 4 and 6. 4 and 6. And we write those as points, right? We don't just say 4 and 6, so we can write it as 4, 0, and 6, 0. So those are, what are those called? X-intercepts. Well, you remember when we learned this form, after we had it factored, then we would do the zero product property, and we would have to solve for x. X minus 4 equals 0, and we found out that our x-intercept was 4. Because we know that our formula is x minus p, x minus q. Okay, so that's what comes before is actually positive. So x-intercept zeros, solutions, roots. Good job.
Does that make sense, guys?
Okay, what about the final one, vertex form, or completed square form? What can we look at and tell? If I look at
-5.
5. What is 5?
What are you finding?
Your period, right?
Yeah, I need an ordered pair. Well, tell me, what are we going to find just by looking at this? What does it tell us? What? The vertex. Okay, it is in vertex form. That gives you a big hint. You're right. It's not. We're not trying to trick you. What? No, our y-intercept was here. This is vertex. Where it gives us our vertex. What is our vertex on this one? 5, -1. So it tells us H and K.
Guys, someone said y-intercept. She said, well, we found it with the standard form. Can we find the y-intercept from vertex form?
Yeah.
Yes. Can we find the vertex from standard form? Yes, we know how to do that, but that's work. We're trying to avoid work at all costs, right? So we want to do it the easiest way. That's why we're saying, what is the key feature that we can get right off the bat? You can still find the other stuff. What would I have to plug in for x to find the y-intercept if I'm looking at the vertex form?
Wait,
What value would I plug in for x? 0. And if I put a 0 in there, 0 minus 5, negative 5 squared is 25, minus 1 is 24. Is that the same answer I got from standard form? Okay? So you can do that, and that's not hard to do. We just are asking what's the easiest thing to get out of it.
Obvious. What's obvious? Just not looking at it. Okay.
And I want to add something to this, if you don't mind. I want to interject. I want you to know that I go to a lot of classes. I visit many classes, and many students are doing quadratics, and they don't know what the purpose of each equation right here. Like you said, the purpose of this equation is you want to find the y-intercept. With this one, you want to find the roots or the zeros. With this one, I can find the vertex. But the question is, are you able to understand that yourself? Because pretty soon you're going to be doing some exercises. Are you able to find these things that we are telling you about? That's the whole point. That when you do these mathematics equations, find out what is the purpose of them. Just doing them doesn't mean anything. You can do anything. So finding what's the purpose of each of those. That's why. So.
All right, we're going to come back and we're going to review it with y'all. So, okay, here we've got two equations. They look pretty similar to me. Could somebody tell me what form they're in? Which one of those three forms are these equations in?
Intercept, right?
It's an intercept form. Now, what would y'all looking at number 4? What is the intercepts of number 4? Is it negative 4, positive 5? Can I write that as an ordered pair? What is it?
Negative 4 from.
Negative 4, 0.
Oh, you just distributed.
Oh, no, yeah. Oh, right, they're called our zeros. That means our y value is 0. Okay. Now, how about number 5? Can I find my intercepts for that one?
Yeah.
Okay.
Is it
Negative
4, 5, negative 5?
No, 8.
No, you're not. You don't negative 4. Just look at it. It's already in intercept.
4 or 5.
Negative 4
Yeah, negative 4 and negative
0.
Positive 5. Positive 5, yeah.
Again, remember, zeros are if you were to set each one of those individual factors equal to 0 and solve it, x minus 5 equals 0, x would have to equal 5. Now, so we see that their intercepts look the same to me. They both start with what?
Negative.
A negative, so what's that going to do?
Opens down. So they're both going to open down, right?
Okay, but I'm probably negative 2.
Well, the negative tells us that it's going to go down, but number 5 has a 2. You're right. Number 4 does not. What does that do to my graph? It's a stretch which direction? Is he going to be skinny or fat? What is he?
Like horizontal or?
Okay, think about slope, guys. If you go up 2 over 1, you're going to get steep faster than if you go up 1 over 2, right?
Yeah.
So a number greater than 1 is going to do what to my graph? I'm not talking about the negative, I'm talking about the 2. It's going to stretch it vertically. He's going to be skinny. Okay, and you're going to need that information when you're looking at some graphs. Not all my graphs stay just like this. Some get wide. That's if the leading coefficient is less than 1, and some get skinny. And I'm not talking about the negative, because people keep saying negative 2 is less than 1. Yes, it is. The negative indicates the direction, whether I have a max or a minimum. Does that make sense? Yes. We're feeling pretty good about that?
Good job.
All right.
Okay, let's just review one more time. Tell me standard form, x squared plus bx plus c. What is the thing that we can find in this form? Y-intercept. So c, right, is my y-intercept. C is my y-intercept. Okay? What about in completed square form or vertex form? What can we find? Vertex. And where do we look for our vertex here?
H.
Okay, H. Okay. And what about factored form or intercept? What do we find there? PQ. P and Q are what are P and Q? P and Q are our x-intercepts.
Right, E.
Yeah. And what's the other word for x-intercepts? Roots, solutions, zeros.
Right. Do you all feel confident that you could go and find the key features and match them up?
Yeah, I could.
Yep.
Okay, I know you can.
I think you can. What? All right. We're going to play a game of dominoes. Can you go back one again? Go back 2. Okay, because of course our dominoes are not going to have dots on them. I know that disappoints you all. But Mr. Johnson, if you could hit that.
Hit this?
The dominoes.
This.
Yeah, it takes a second to come up with. And you have to make it bigger.
How to play dominoes. Use these tips to organize a game of draw dominoes, the most popular domino game played today. You will need a standard set of 28 dominoes, a large flat surface or table to play on, 2 to 4 players, and a pencil or paper. Step 1. Place all the dominoes face down on the table and shuffle them around. Have each player select their dominoes, keeping them in. If 2 people are playing, each person gets 7. If 3 or 4 people are playing, each takes 5 dominoes. There are 28 tiles in a standard set, from blank at both ends to 6s at both ends. Dominoes are also known as bones. Step 2. To decide which player starts, each player reveals their highest double, a piece that has the same number of dots on both ends. Whoever has the highest double goes first. If none of the players drew a double, then whoever has the heaviest tile, the domino with most dots on it, goes first. Step 3. The player begins by placing their heaviest domino face up anywhere on the board. After the first move, players must match the number of dominoes on one end.
Okay, that's where I want y'all to see, okay? This one, y'all see how the 5s are the same? They're not really related to each other. Even though they're the same, they just happen to be on the same domino. Right here, these are another domino. They're on the same domino. They do not go together, do they? No. No, this 5 matches this 5. This 4 matches the 4 on this domino. That's how you play dominoes. You're going to connect the ones that match. Did everybody understand that? Okay. Dominoes is a lot of fun, and I know people don't really play it anymore, but if you look up some games of dominoes, they're simple and they're fun. But for our purposes, what we wanted you to see was we're going to be playing dominoes, and you all don't have to play with boring dots. You all get to play with quadratics. Okay? And we can make a set to take home and play too. If you can go get into your envelope in your bucket, you take your dot. There should be a set of dominoes.
We'll get out here.
You want to know what he just he just asked me at the end of class when I listened to the quad song.
Yeah.
We played a video. I have to just let you see because you will. It involves the administrators, and they get say, "Oh, I thought it was beginning, but do you know quad song?" No, you're not. Quadratics. They went out and said it.
No, only one per group. You only need one set of dominoes per group. Because we have 7th periods in there too, so only one in there. I mean,
Okay.
per group.
You should take out. There should be 10 dominoes, guys. So, and you might have to kind of, play with them because they stick together. Find your domino that has an H on it. Okay, and pull it out. And once you have it, you can look up here so we know everybody's ready to go. We're going to put the first 3 dominoes together. Okay? We're going to do it together. And then your group is going to have to complete the dominoes so that they make a rectangle. And I'll show you a class that did it before so you get the general idea of what it should look like. I took them down just so that you all could do it all on your own because I know that's how this class likes to do it. But it's going to look like this. Oh, you're just seeing the answers. Okay, looking at our H. Does everybody have the H pulled out? Let me look at the first equation. What key feature do we see in this one? The y-intercept, the C. What is the C? 0, 15. Okay. What key feature number I can get here. Whatever this is, when I square it, what is it? It can't be any smaller than 0. Would you all agree? So my lowest point is going to be whenever this equals 0, since that's as low as it can go. And so what value of x will make x minus 4 equal 0? 4. And when it does equal 0, you've got a negative 1. Does that make sense at all? So I thought that was a pretty clear way of, you don't just take the opposite. That's why it works. So we've got our key features here. We want to go find a domino that has a graph that has a y-intercept at 0, 15. It crosses the x-axis at 3, 0, and 5, 0. And it has a vertex of 4, negative 1. So see if you all can find that.
Go through your card, see what it would match up to the left of our H domino. Find your H domino. And then look at yours here. Look at the key features right here. It has a y-intercept.
We're looking for that graph. So look at the graphs. Don't worry about the other equations.
Come on. Well, that is the y-intercept of 15. Is that y-intercept 15?
Y'all have it?
Right. Where's your H?
Good.
Oh, okay.
Did y'all find one?
Y-intercept.
Hi.
So you have a y-intercept of 15. I agree. Your x-intercepts are
Help her find the graph that has those features.
So when we play dominoes, we match it up like that. Okay, what I do like this is.
Well, no. Which key features did we find? Did we find them for the equations or for the graph?
So they be going from them?
You got it? All right, guys. It looks like y'all are getting that. So our first two dominoes should be an A and an H, right? Now if we look at the other side, this one we have to we can see the key features, we just don't see them in an equation. But that's okay, we know how to write equations based on the features, right? What point is this?
Say it.
I can't see that.
Well, look at your maximum.
It's my maximum. So what kind of equation could I write from this? My vertex, can you help me out? What did we say to find the vertex, to find the x value we would have to do? We were trying to find what made it equal to...
Is it HK?
Uh-huh.
How would you write that in vertex form? How would you write that in vertex? X plus 3 quantity squared plus 25.
Is there anything else I need to know, Aaron? Anything that stands out to you about this graph? Well, it does cross the y-axis, but we don't know where. But just looking at it, without knowing any numbers, what's my graph doing? It's got a negative.
Good job.
Leading coefficient is negative, right? That's what you said?
Now, we could also find the intercept forms. If that's a negative 8, what would my intercept be?
How would we write it in the intercept form or factor form?
This is negative 8 and positive 2.
X plus 8, yes. And X.
See if that helps you all find the domino that's going to go to this side. That's not what we have up there, is it? I've got x plus 8, x minus 2.
Got it? And,
Good? Okay, where's your h in your... Okay, we're looking for the one that goes to this side.
okay, you got it?
And it's one of your ones that are still free.
3, negative 3, positive.
Okay, so that we can get you all going on time. It should be A-H-E, okay? Now, you all as a group or a pair, you need to complete
he think?
Is Justin with us today?
Yeah, he's there.
I'm here
How do you go across the top?
And I 3 or 4 doesn't matter.
You got negative 4 and positive 4. You also know your y-intercept here. See?
It's intercept.
It's really easy.
Are you sure?
Really close to it. You need to be helpful then, because they might make mistakes. You don't want to trust these guys with your grades. You better kind of help them. Oh, guys, Megan just asked a really good question. Are we supposed to do anything with the ones that aren't filled in? For right now, just leave them as they are. Once we get them put together, I'm going to have you go back and fill that information in. Okay? Now, if it absolutely would make you feel better, because me, when I was doing it, I wrote them in because it made me understand it a little bit better.
That's all that it tells them. And we can feel that. We'll do that later. So now you're looking for
Yeah, that's good. And then, you know your y-intercept is 16. If you were to multiply with negative 1 times positive 4, would you get a negative 16? Does that help? Did you all see the key?
I was sorry.
So it's not going to be this. That's
I can't see the numbers that well.
You know, so,
Oh, we know that.
Okay, well, tell me this. What if we had a so it's our
Ariana, why would you even ask me that? Of course it's right. Move it over so y'all can have a little bit of room. And you can also go this way. I mean, you had a factor 35, what multiplies to 35 and adds to 2.
you go in.
Because there's one that's more difficult than the others.
Yeah, do it.
You got it?
That's good. Yeah.
At some point, y'all are gonna have to do some turning because you're gonna run out of. Yeah, that's fine.
So that
That's
is,
whatever works for you.
it does open up. Well, it's not in Vertex form, honey, now. No, that's intercept. Yeah, intercept. And the intercept is what?
I'm sorry.
I was looking at the intercept is 4.
Well, these are right because I did them.
One time, right? So, yeah, good.
Yeah, you're good. You're good.
Now this is special.
everybody else get it.
Guys, this group right here, if you go look and one of you go and check out theirs, and one of you all come and check theirs and make sure that they have it correctly. And then yours is to defend, if he's like, I don't do that, yours isn't right. Nope, that's good.
We all good?
That's it. Tell me what you do. Okay, so starting pointing out, so you know it matches with a positive, right? Okay, what about where it crosses out? You know, why I saw
Up or down?
So we're looking for a y-intercept of 16. And what kind of factors will should have?
They do.
Yeah, Vertex form, standard, I mean, I'm not putting words in my mouth. Intercept form, if that is my,
Here you go. Right.
what are my factors? Look at some of the ones that
Right. Make sure, listen guys, you should have a glue stick in your bucket. When you do it, it's very easy. When you're gluing, you get it out of order. Man, I'm coming your way. It's right. Go check it out. You don't? Oh, I'll give you one.
All right.
No root. What is that going to do? Where's he going to do that?
What y'all gonna do after you glue it down, is you all are going to
That's the paragraph.
set of three,
I agree.
okay? Of your
Another
group.
wall right here. My leading position is on
So as you're gonna take the glue down,
Right.
Help?
Well, you are leading position too.
Crosses the x-axis.
Now let's find out where
Does
it
it? Does it have a y-intercept?
goes together. A.
Oh. I shouldn't have probably said that word, but right away you draw on yours.
Yes, so what now?
okay, that looks good. Okay, I'm gonna get you some paper to glue down, and then I want you all to create 3 dominoes. Okay, let me get you the paper. Do you have a standard?
Yes, there is a bucket. Okay. Now, I don't know.
Yes. Hey, Dariana, will you come check theirs for me? Yes.
Okay, let's check this. Keely,
original, that original pre-assessment that we took last Thursday that I said I used to put you in the groups. Hopefully now you all can look at an intercept form and match it to the graph. Okay, because you've gone through this process.
Mr. McKallip, you said homework, didn't you?
It's going to be due Thursday. Tomorrow they collect the bookwork.
So we did last one.
Yeah, let me write it up here so I remember it. I know.
You don't send out
I do what I remember.
Mine says
I need to remind 101 to do my remind 101.
Yeah. I have to think. Like you guys get. Miss McKallip, is that her name?
Yes.
Come back to us.
That's it. You put it right in the middle. Then you put it on the front.
I just like.
I knew it.
I figured it out when they were watching it. Yeah.
Alright guys. Cheyenne, can you go ahead and have a seat, please?
I was still gluing in her seat. Yes, she's saying my seat.
That looks great, guys. Okay. Guys, if I can get your attention, I know some people are still gluing. Okay, guys, I know some people are still gluing, but I wanted to just do a quick summary of what we went over today, okay? So as you finish up gluing, I want to get them up, and then I want to make sure I get your dogs. I don't want to get behind in your dogs again, because that's just painful, trying to stay up with these dogs. I've got new ones. Okay, but can somebody tell me one thing that they learned today that they didn't know or didn't necessarily grasp before? Healing? Guys,
it didn't form. Okay.
pulling out from Vertex form? Okay, so Vertex form, or what's another thing that they call the Vertex form? Completing the square? So our key feature is our vertex, right? Okay, anybody else not realize that the key feature was so important based on the form? Kendra? Oh no, you don't share? You didn't know that? How about the standard form? What was our key feature? The y-intercept, did we know that? The key feature is the y-intercept. How about the intercept form?
You gotta find Vertex.
The vertex, when we find the vertex, what else does the vertex represent? One of our key features?
Symmetry.
Well, it does, but that's not one of the key features we're talking about.
X and Z.
So max or min? Okay, and our standard is y-intercept. Our intercept form is our roots. Or our zeros. Okay? Now, Miss Johnston is bringing around that paper. I'm going to come around
I got you right here.
Everybody.
You all did do pretty good. You were there.